Okay, and here we are in our coordinate geo review. Okay, so it says find the length of AC, and I want you to recall that this word length is often used in place of asking you to find the distance. Okay, and I actually kind of want to show you guys how to do this in two different ways, but let's first start with our traditional distance formula. So we can say, you know what, our distance is going to be this: x2 minus x1 squared plus y2 minus y1 squared. So if you're ever stuck, you can always use this, and it is essentially foolproof. Okay, so let's first go ahead and label our point A. Let's see, I see it right here. This is the number 3 on the x-axis, and since it's on the x-axis and has not shifted up or down, my y value must be 0. I also see here for the letter C, I see it's gone a distance of 6 to the right, and it's gone down 1, so we can call that 6 comma negative 1. Well, of course, we know this is x1, y1, and let's call this x2, y2, and we can fill in everything that we know. Now let's use a little purple here. Now let's say, you know what, we know that our x2 value is going to be 6 minus our x1 value, which is, of course, going to be 3. Now we close our parentheses, we square it, plus parentheses. And looking here, I see, oh, you know what, my y1 value, or I'm sorry, my y2 value will be negative 1. Almost made a mistake, huh? And minus my y1 value, 0. And of course, we can now square it. Okay, so what does this look like in our next line? Well, of course, we do the easy things. We combine our terms inside the parentheses, and 6 minus 3 will, of course, give me 3 squared, plus, and negative 1 minus 0 will give me negative 1 squared. Here, I can say d is equal to the square root of, well, I know that 3 squared is really 3 times 3, which of course is 9, plus, and wait a second, well, what about negative 1 times negative 1? Well, negative times negative is a positive. And here we can say this: d is equal to the square root of 9 plus 1, which would of course be 10. d is equal to the square root of 10. Now, what if I asked you to solve this another way? Well, what I would ask you to do then is I would actually ask you to draw yourself a right triangle in between these 2 points. Okay, and why is a right triangle useful? Well, we know that anytime we have 2 sides of a right triangle, we can use a squared plus b squared equals c squared. And of course here, when you look at this, remember, I always ask you to draw an arrow that points to the letter C. Well, I know this distance. That's a distance of 1 square. I know this distance. That is a distance of 3. Okay, well, if my C term is my unknown, and I know that my A term why not? Can be 1 squared plus our other side, 3 squared. Well, what do we get? We know that 1 squared is 1, plus we know that 3 squared is 9 is equal to c squared. Oh, and this should start to look a little familiar. What is 1 plus 9? Well, that's 10 is equal to c squared. And how would you get rid of a square? Well, of course, we could take the square root, and we'd say c is equal to the square root of 10. That is 2 distinct ways to solve the same problem. All right, let's move on. Okay, here we are on example 2. It says find the length of, oh, wait a second. Find the length of DE and the length of AC, and how do these 2 lines compare? Well, I would hope you know this. If a line is either perfectly vertical or perfectly horizontal, you don't need to use the distance formula. You can actually just count. So look, 1, 2, 3, 4, 5, 6. And what about down here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, how does 6 compare to 12? I would say this. I would say that line DE, which is of course this one right here, is half the length of our bottom line AC. DE is half the length of AC. And let's move on. Okay, let's take a look at number 3. Number 3 says find the equation of the line parallel to 3x plus 6y equals 18, and of course passing through the point 4, negative 3. Well, I hope you would realize at the very outset that whenever we have 3x plus 6y equals 18 and our x and our y are on the same side, we are talking about a line that is in standard form. And in order to find the slope, we first have to get y by itself. So what would we get rid of first, the 3x or the 6? And hopefully by this point you would say, you know what, we're going to move our x term first. We will subtract 3x from both sides. Of course, that zeroes out, and I have 6y is equal to negative 3x plus 18. Well, how will we get rid of the 6? We are going to divide each term by 6, and we'll get y is equal to, here we have negative 3 over 6, which reduces to negative 1 over 2x, plus, and here we have 18 divided by 6, which is 3. Now notice, just doing this is not enough to get the answer by itself, but it is enough to get us started. It shows us that our M1, our very first slope, is going to be, in fact, let me use a different color here, is going to be this negative 1 over 2. And we draw our arrow, and we say, you know what, hey, our keyword here is going to be the word parallel. And guess what? We know that parallel slopes are the same. So the slope we'll use is negative 1 over 2. The point we'll use is 4, 3. Don't forget to label that x1, y1. And our point slope formula is y minus y1 is equal to m parentheses x minus x1. And now let's plug these things in from left to right. I know that I have y minus my y1 value, which is 3, is equal to my m value, negative 1 over 2, parentheses x minus x1, which is 4. And of course now all we have to do is simplify and then get the y by itself. So we have y minus 3 is equal to negative 1/2 times x will of course give us negative 1/2 x. And I want to give you all a special little trick. We've done this so many times now. Firstly, a negative times a negative is a positive, but whenever you multiply by 1/2, it's actually the same as dividing by 2. So what is 4 divided by 2? 2. And from here, of course, we know to add 3 to both sides. And we get this. Y is equal to negative 1 over 2x plus 5. Alright, I hope that helps. Okay, here's our fourth and final example. And it says this. Find the midpoint of DB. Now I know that from D to B is here, and our midpoint should be somewhere here. Well, let's go ahead and label what D is. D, it turns out, is negative 7, comma, negative 1. And it turns out that B is going to be negative 3, comma, 2. Well, let's go ahead and always label our points. I like to call this x1, y1, and of course x2, y2. So what does that look like when we plug it in? Well, I'm going to initially write our formula where everything that we won't change will stay in orange. But let's go ahead and plug in our values in this purple. I see that my x1 value is negative 7, and my x2 value is negative 3. I see that my y1 value is negative 1, and my y2 value is positive 2. Okay, so moving forward, what does this look like? Well, we have negative 7 plus negative 3, which will give us negative 10 over 2. We have negative 1 plus 2, which will give us 1 over 2. And guys, from here, this is fairly simple. We know that negative 10 divided by 2 will be negative 5, comma, 1/2. And here are your 4 answers to the previous 4 problems. Alright guys, I hope y'all enjoyed this lesson, and I'll catch y'all in our very next lesson.